Thank you and good afternoon, everyone. So today my topic is evaluating the environmental footprint of X-Road, and before diving into the topic, I will give you a little bit of background first. So let's start from the organization that I represent, the Nordic Institute for Interoperability Solutions, NIS for short. NIS is a non-profit association which mission is to develop digital government solutions to its members. And currently NIS has three members, the governments of Estonia, Finland and Iceland. And NIS has two main products, X-Road and Harmony e-Delivery Access. They are both solutions for secure data exchange. The main difference is that X-Road is for national data exchange, while Harmony is for cross-border data exchange. And today I'm going to concentrate on X-Road. So what X-Road is? X-Road is an open source software and ecosystem solution that provides unified and secure data exchange between organizations. X-Road is also a digital public good verified by the Digital Public Goods Alliance. X-Road is used worldwide. We are aware of 23 X-Road ecosystems, and in the countries where X-Road is being used, there are over 540 million inhabitants. And this is how it looks on a map. So even if X-Road is a European solution, you can see that the strongest area for X-Road is the Latin America. But besides Estonia, Finland and Iceland, in Europe, X-Road is also being used in Germany, but not on a national level. It's a private use case there. In many cases, data exchange solutions, they are domain specific. So for example, healthcare, transport, and so on. But typically X-Road is used as a national data exchange solution, which means that within a single X-Road ecosystem, many different kind of organizations are using it, and all kind of data is being exchanged. And this is the case in Estonia, Finland and Iceland. X-Road is based on a so-called four-corner model, which idea is that information systems are not connected directly, but instead they communicate through unified access points. In the X-Road architecture, the access point component is called the security server. So every organization has its own security server or multiple security servers that are used to exchange data between other organizations. And X-Road is not only a technology, it also has its own governance model. The X-Road operator is the organization owning the X-Road ecosystem. The operator defines the rules and policies that the ecosystem must follow. And then there are service providers and service consumers who are members of the ecosystem. But then when it comes to sustainability, of course, sustainability is an important topic for NIS, not just regarding X-Road, but regarding the whole organization. But regarding X-Road, sustainability can be divided into three different areas: X-Road governance, sustainability in X-Road, and sustainability by X-Road. And today I'm going to concentrate on sustainability in X-Road. And NIS is responsible for developing and maintaining X-Road. In practice, we have a team of outsourced software developers who are doing the development work. Then X-Road operators and X-Road members, they are the users of X-Road. X-Road members have their own information systems that are connected to X-Road, and they use X-Road to provide services to end users, usually citizens. And of course, all these aspects, development, operating the system and using the services, they all cause environmental impacts. And today I will mostly concentrate on the operative environment part. And X-Road also contributes to the UN's Sustainable Development Goals. All in all, there are 17 goals, and X-Road contributes to 8 of them. I'm not going to go into the details today, but if you are interested in reading more about this topic, there is more information available on the X-Road product website. And then that was the background part, and now the actual topic, which is measuring the environmental footprint of X-Road. So we started to work with these environmental aspects 3 years ago, and the very first step was a study that we conduct together with Go4, that is a Finnish consultation company, and the Stockholm Environment Institute. And the aim of the project was to measure X-Road's environmental footprint, or not actually measure, but to estimate it. And the study was divided in 3 phases. So first we needed to define what are the factors that cause environmental impacts when using X-Road, then to build a carbon footprint calculator based on that information, and finally also define recommendations for improving X-Road sustainability. The very first step was to define the emissions boundary. And well, this is the technical architecture of X-Road. Not going to go into the details. The main point is that the security server, as I explained earlier, it is the most important component when it comes to the data exchange. There are also other centralized components, but they don't play active role in the data exchange, so that's why they can be ignored in this case. And also, of course, the information systems that are connected to X-Road, they generate emissions too, but since they are kind of out of X-Road scope, out of our hands, they were ignored too. And therefore, we decided to concentrate on the security server component, because it's the most essential component for the data exchange, since all the data flows through it. The main sources of carbon emissions on the security server are the security server infrastructure, so CPU and RAM, data transfer, and data storage. And after identifying the main sources, we looked into the existing research data, best practices, and operational data collected from Estonian and Finnish X-Road ecosystems. And based on that information, we developed a model to estimate the environmental footprint. So first we developed a model to understand the electricity burden of one X-Road security server, and then after we had developed the model for one, we could use the same model to estimate the footprint of an entire X-Road ecosystem, well, just by multiplying it by the number of security servers in the ecosystem. We needed to do several assumptions when building this model regarding the technical details of the server model, what kind of memories is used, and so on, but also regarding the actual workflows. So we were assuming that the servers repeat a weekly pattern of data processing. Since we didn't have more detailed information available at this point, we needed to do these kind of assumptions to be able to get some results out of the process. And what I didn't mention earlier, X-Road is based on a decentralized architecture. So all the member organizations using X-Road, they have their own security servers. They are free to decide what kind of infrastructure they are using to deploy them. That's why it's very, very difficult to know what they are actually using, and we needed to make some assumptions. Then regarding the data transfer from the literature, we found a value that we used in the estimations. And also regarding the data storage, we needed to make similar assumptions regarding the infrastructure that the organizations are using. But then besides the energy consumed by the security servers, we also needed to consider the energy that is consumed by this supporting infrastructure like cooling, lighting, and so on. And that's widely considered in the industry through a factor known as the power use effectiveness, PUE. And in this project, we used the value of 1.58, which is a, average value for an on-premise data center. And the smaller the value is, the better it is. For example, the big cloud providers, Amazon, Microsoft, Google, in their case, the value is pretty close to 1. So the total energy consumption of a security server is calculated as a product of infrastructure, data transfer, storage, and PUE. And then at this point, we know the total energy consumption of the security server. Then we still need to convert it into an estimation of released emissions. And that is done by multiplying the consumed energy by an emission factor for grid electricity. And the emission factor, it basically says how dirty or clean the grid electricity is. And this value, it varies between different countries, and it also varies within a country, and it can be different depending on the day and time of day. Which means that running exactly the same workload generates different amount of emissions depending on where it is run and when it's run. And here on the table you can see some example values for some European countries. So for example, if you look at Iceland and Estonia, the difference is pretty big. And then based on these findings, we developed a calculator that can be used to estimate the energy consumption of a single security server or an entire X-Road ecosystem. It's an Excel-based tool. It's available on the X-Road website. You can download it. You can play with it. The user must provide some information as input. For example, the number of security servers, are the server hosted on-premise data center or on a public cloud, number of the amount of data that is being exchanged and the amount of data that is being stored. And then the calculator gives the results, summary of results, visualization, and then also a more practical example what these numbers mean. So how many round trip flights from Tallinn to Lisbon the results equal to, because I'd say that for most of the people seeing only the numbers, it doesn't say much, including myself, but you get a lot better picture what those numbers actually mean when you get this kind of a more practical comparison. And then we use this calculator for the Estonian and Finnish X-road ecosystems to compare them. And the environmental footprint of the Estonian ecosystem is higher than the Finnish one. Not a big surprise. You saw the electricity factor earlier. It was a lot higher for Estonia than it was for Finland, and also the Estonian X-road ecosystem is bigger than Finland, so not surprising. What's maybe a little bit surprising here is that the biggest part of the emissions it comes from the servers, so CPU and RAM, and only a very small part comes from the data transfer and data storage. So only 1% comes from data transmission and 3% from data storage and 95% from the infrastructure. The study produced also some recommendations. Well, because this was a study about X-road, the recommendations are X-road specific, but many of these, they are, well, on the other hand, they are also quite generic, and they can be applied to any software product. So for example, flexibility to disable certain functionalities so that you can disable or not to install features or components that are not actually being used. Also providing the users with clear information and instructions how to support emission reduction strategies, for example, permission to use public cloud services, what kind of logging is needed, retention periods, and so on. Then the use of renewable energy, use of power efficient devices, and then of course, since X-road is just a supporting service for other information systems, then how to implement and operate the information systems that are connected to X-road also plays a significant role when you think about the total environmental footprint and not concentrate only on the security server. Here I have listed some factors that affect the carbon footprint of a software product. For example, the programming language. There's quite big difference between different programming languages and how energy efficient they are. Here there is a link to a study on the topic. The most energy efficient programming language according to the study was C. And the least energy efficient, I think it was Python. X-road is implemented using Java, which was fourth or fifth most efficient. But yeah, we got lucky there, so we didn't choose the language based on that information. And in practice, if you have an existing information system, you cannot just easily change the implementation language, even if you would like to. Then it's another thing if you are starting to implement a new information system, you have more freedom when choosing the programming language, but still I wouldn't use this kind of listing as at least not as the only criteria for choosing the language. So even if the C language is the most energy efficient according to this study, it might not be suitable for implementing all different kind of information systems. But then there are also several other factors that should be considered: architecture, design patterns, use of dredge, caching, use of external libraries, and development practices. If I think about potential low-hanging fruits on this list, they fall under the development practices, definitely. So if you want to start reducing your environmental footprint, some very easy things to do are, for example, in your development environment, if you have a lot of servers, we definitely do have. So usually it's not necessary to keep them running 24/7. So keep them running only when you need it. Nowadays we shut down all our servers in the development environment outside of office hours. So they run only when we need it. Another easy way is to optimize your pipelines. So, for example, you might be running some automated tests for each commit. You could consider that is it really necessary for each commit, or would it be sufficient to do it for every pull request, for example? And that way you can very easily reduce your environmental footprint, and you don't need to do any changes to your software. And the other things listed here, they of course they require some changes to your software, and they might be more difficult to implement. We have implemented some changes to the X-Road software. So message logging, it's one very important feature in X-Road. So we have developed it so that it can be entirely turned off, and we have also provided better documentation regarding the logging and different configuration alternatives, so that the users can make informed decisions about how they should configure their logging and not just log everything always by default. Then we have also made the software more modular, so that you don't need to install components that you don't necessarily need, and better support for public cloud. And then about development practices, I already mentioned changes that we have implemented to our development environment, but other things that we have done are listed here. For example, we developed an online training, sustainability in software development. First, the idea was to offer it to our own development team, and so that every developer in our development team during the onboarding process must complete the course. But then eventually we decided to publish it so that it's available to everyone free of charge. And here's a link to the course. Then, the other things that are listed here I already mentioned. Then here's the next steps. So overall, I feel that we are maybe I wouldn't say that we are in the beginning of this journey, since we've already been working on this topic for several years, but definitely there are still a lot of things that we can do, that we can improve. Last year we conducted another research project, this time with the University of Helsinki. We are continuing this year with another research project with the University of Helsinki. And we are also applying the principles of green software engineering to the X-Road development process. For example, we are starting to evaluate the environmental impacts of new features. So we are using Scrum for our software development process, and in Scrum you estimate the complexity of every new item, every new feature. Similarly, we start to estimate the environmental impacts of every new feature, and then we also start measuring the changes in the software. So before implementing the feature, we try to evaluate the impact, and then after we have implemented the feature, we aim to measure how does it change the software and the environmental impact. And there is an open source tool called Green Metrics tool that we are going to use for the measurements. It's not the only tool available. There are some others as well. But at least in our case, that was the best fit to our needs. If you are running an online service, a website, then there are a lot more alternatives to choose from. But in our case, we needed a little bit different tool, but Green Metrics tool was a pretty good fit. And here's a link to the website if you are interested in looking into it. But yeah, that's all that I wanted to share with you today. Thanks for listening, and I think maybe we have time for questions. Thank you.
Thank you.